All right, we're going to do one more example, graphing exponential functions, 2 of them on one xy plane. And then to finish up this video, I've got one trick question for you after this. So hopefully you're starting to memorize what the values are for 2 to the x. 2 to the negative 3 is 1/8. 2 to the negative 2 is 1/4. Then we get 2 to the negative 1, which is a half. And then we get a 1, a 2, a 4, and an 8. 2 to the third is equal to 8. I'm going to go ahead and graph that again for about the third time. 0, 1, 1, 2, 2, 4, 3, 8, negative 1, a half, and then a fourth. So we're getting good at this graph. All right, so that is f of x equals 2 to the x. Now, just like last example we did, I'm not going to fill all this in. Let's just use transformations of functions. What does the graph of g of x look like compared to this? What did we replace x with? We replaced x with x plus 3. So which kind of a shape is that? Up, down, left, right. It's going to be a shift left 3. So again, we replaced x with x plus 3, which means shift it left 3. So I'm going to go to all the points I had chosen already and just go exactly 3 to the left. This one, go 3 to the left. This one, go 3 to the left. This one, go 3 to the 3 to the left. And this one, go 3 to the left. And so on. I'm going to get really close. They're going to get really close here because of the pin I'm using here, but they really should never touch. This one will always be just slightly above the graph of x. G of x is 2 to the x plus 3 is that graph right there. So it should be fairly clear that the graph of g is the graph of f just shifted 3 units. All right, so here is my trick question for you. I shouldn't have said it's a trick question, but true or false? The graph above of y equals 2 to the x plus 3, that's this one right here, g of x equals 2 to the x plus 3. How did we get there? We took this one and shifted it left 3 units. But it could also, true or false, be obtained by vertically stretching the graph of y equals 2 to the x by a factor of 8. Okay, so the claim is, or the true-false question is stating, to get this graph right here, I could have just taken this one and multiplied it by 8, which makes it 8 times as tall. All right, and let me give you one simple point. What's the height of the function of f here? What's f of 1? 1. I'm sorry, f of 0 is 1. What is g of 0? 2, 3, 4, 5, 6, 7, 8. 8 times. So that doesn't prove it true or false, but it might work. And let's look at another point. At negative 1, it's a half. 2 to the negative 1 is a half. But g to the negative 1 is 2 squared, which is 4. 1/2 times 8 gives me 4. So far, the 2 points we've checked make it perfect. They work successfully. But how can we argue this? It is true. May not seem like it, but stretching this graph, well, let me start with shifting it left. you'll get exactly the same graph as if you just took it and stretched it up by 8. I know that seems weird, but there's an easy way to prove it. Okay? What would we expect it to be if we stretched it by a factor of 8? If you had f of x and you want to stretch it by a factor of 8, you just put an 8 out in front of it. That would be stretching it by a factor of 8 vertically. Well, here's how we can show it very simply. Y equals 2 to the x plus 3. Well, if you remember your exponent rules, I'm going to use this one. A to the m, a to the n equals a to the m plus n. Remember that exponent rule? Well, how could I break this down going in the reverse direction? That's equal to 2 to the x times 2 to the third. What's 2 to the third equal to? 8. So indeed, the graph of y equals 2 to the x plus 3 may be obtained by vertically stretching the graph of y equals 2 to the x by a factor of 8, because this 2 to the x plus 3 is also equal to 8 times 2 to the x. So kind of a fun problem to think about.